Hi, this is your math facilitator, Naomi Andrag. I'm going to go over this example of graphing an equation that's in slope-intercept form. Slope-intercept form looks like this. It has y equal to some number times x plus some other number. Now, we'll find that this number that's multiplied times x is the slope. It's how the line kind of changes from one point to the next. And this this number right here, 2, is how we get our y-intercept, because when we put 0 in for x to get our y-intercept, this part goes away and we're just left with the value of 2 for y. So one way to graph is to make a chart like I've done down here, and a second way to graph is to use the y-intercept and slope. I wanted to start by making the chart and then show how that relates to finding the slope and y-intercept. So if I use the chart, I would just pick arbitrary values for x. I pick values for x that are easy, and I recommend that you do the same. So one value I almost always pick for x is 0, because if I pick 0, multiplying anything times 0 isn't too hard, because anything times 0 is 0. So I just change this x value to 0, and I'm going to get y equal to 2, because this whole part is 0. So my point there, xy, is going to be 0, 2, and that is going to be the y-intercept because it's on the y-axis right here, over 0 up 2. So if I were going to graph that point, it would look like that. Now back to my chart. I have to think about what other numbers I'd like to use for x. Now, since I have this funky fraction out in front of x, 3/5, I want to pick a value for x where I can take a fifth of it, right? So that makes sense. I wouldn't want to pick 1 because 3/5 of 1 is 3/5, and then I'd have fractions to graph, and who wants to graph fractions? I'd want to pick a multiple of 5 because I can take a fifth of 5, so I can take 3/5 of 5. Or 10, I can take a fifth of 10, so I can take 3/5 of 10. So my values for x here are just going to be multiples of 5, that denominator, so that this denominator of this fraction, so that when I multiply the fraction times the x value, I end up with a nice, beautiful whole number. So substituting in, I'm just going to go straight through. Here my x will be 5, here my x will be 10, here my x will be 15. Now a fifth of 5 is 1, so 3/5 of 5 is going to be 3 times as much, so that's going to be 3 plus 2, and so that gives me a y value of 5. So I can stretch this out a little bit so it'll fit. There. So my point there is going to be 5, 5. Now, here, a fifth of 10 is 2, so 3/5 of 10 is going to be 3 times 2, 6. So here I have 6 plus 2, and so that gives me 8 for my y value. My x value is 10. My y value is 8, and so my point is 10, 8. I'm not going to do 15 because it's going to be off the graph anyway. So over here on my graph, 5, 5 is going to be right here, and then 10, 8, see, I might have to go over a little bit. 10, 8 is going to be over 10, up 8, right there. See, point, okay. And so the graph of this line would go through those points, looks like this. Now, the shortcut way is to just use the y-intercept and the slope, and I can get them directly from the equation. So this number is always the y part of the y-intercept, so just going straight from the equation, I would know the y-intercept right away is 0, 2. You just ignore that part to find the y-intercept. And the slope is this number in front, 3/5. Now, the second way to graph utilizes this. I just start at the y-intercept right there, and then I get the next point by moving up 3 and over 5. Up 3, over 5 gives me another point. If I draw the line through these points, I get exactly the same line as I did by finding the chart. So that way is a little shorter